Welcome back to VKP Online Tutorials. Today we'll discuss assignment problems on maximization time. So how to solve the problems in maximization time. So in previous session, I already explained what is maximization time and how to convert this profit matrix into cost matrix. Just look at this problem. So in this problem, solve the following assignment problem is given matrix and is saying the entries indicates the profit. So he's saying profit means this problem belongs to maximization. Whenever the elements, if they mention the profit, so those problems are belongs to maximization time. And we need to find who will be the ideal person for this assignment problem. So whenever the maximization type problem is given, so we need to convert maximization type problem into minimization type problem. So that is a profit matrix is converted into cost matrix. So how to convert the cost matrix? Let us see the conversions of the cost matrix. Now look at this matrix. So in the matrix we have 5 rows and 4 columns. So it is 5 by 4 matrix, 5 by 4 matrix. So that's why this is unbalanced. This is unbalanced and also maximization type problem. So this is unbalanced and maximization type problem. So we need to make it into balance and also convert it into a cost matrix, then apply a Hungarian method to determine what will be the optimum cost and optimum assignment. So how to convert, say, I'll take this problem. So to convert unbalanced into balanced, we need to introduce either dummy row or dummy column. So for this problem, since we have 5 rows and 4 columns, so I'll introduce one dummy column to make it balanced. So now I'll introduce a dummy column to make the balance. See, now here I am introducing one dummy column. This is 0, 0, 0, and this is 0. So I introduce a dummy column to make the balance. Let us take this is some J5. Assume this is a J5, job number 5. So now this is become, now it is balanced. Now this matrix become balanced. Now we need to convert this maximization type into minimization type, or we need to convert the profit matrix into cost matrix. So this is a profit matrix because it's given the profit. Say for to assign P person 1 to J1, this is the profit we are earning, that is 11 rupees. And similarly, if you assign P1 and J2, we are earning 3 rupees will be the profit. Similarly, P4 and some J3, we are earning 12 rupees will be the profit. So convert the profit matrix into, next step is to convert profit matrix into cost matrix. So to convert this profit matrix into cost matrix, identify the maximum number in the profit matrix. So here the maximum profit. So in this case, the maximum profit is 13. 13 will be the maximum profit. So I will subtract the other elements from 13 to obtain the cost matrix. Let us see how to write the cost matrix. I'm writing the cost matrix for this one. So now in this case, maximum element is 13. So now I'll subtract from 13. Say 13 minus 11. So this is 2. Then 13 minus 3 is 10. Then this become 8. Similarly, this become 5. This becomes 0. then this becomes 0, this become 9, and this become 5, this become 4, and this becomes 4, then this is 3, this is 10, this is 8, this is 3, and this is 0, then again this is 0, then this become 2, this become 1, this become 0, then this become 9, then this become 5, this become 4, this become 3, this is 9, this is 0. So now this is the cost matrix. So this is my cost matrix. This is my cost matrix. So now next step is apply Hungarian method to determine the optimum cost as well as as optimum assignment for this problem. So now to apply Hungarian method, we need to follow these steps. One is row reduction, then second one is column reduction, and third one is allocation to check the optimality. Again, if you are not getting optimality, so we need to do reallocation. That's the last step we need to remember. Okay. So now I'll go with row allocation. So in a row allocation, identify the minimum element in a row and subtract other elements by that minimum element. Say in this case, the minimum element is 0. I'll subtract 2 minus 0 is 2, 10 minus 0 is 0, 8 minus 0 is 8, 5 minus 0 is 5, and this becomes 0. Similarly, this one, the third row, fourth row, fifth row, and fifth row, we are getting this will be the row reduction. I applied row reduction. It's very simple. Let us see row reduction, out of the row reduction. In this case, minimum element in the first row is 0. So 2 minus 0 is 2, 10 minus 0 is 10, this is 8, this is 5, this is 0. Similarly, in the second row, the minimum element is 0. So this becomes 4 minus 0 is 4, this is 4, this is 5, this is 9, this is 0. In the third row, the minimum element is 0. So this becomes 3 minus 0 is 3, 10, 8, 3, and 0. Then this one is minimum element in the fourth row is 0. So 9 minus 0 is 9, 0 minus 0 is 0, 1, 2, and 0. Similarly, in the fifth row, minimum element is 0. So this become 5 minus 0 is 5, this is 4, this is 3, this is 9, this is 0. I applied row reduction. Then I'll go for column reduction. So I'll take this matrix. I apply column reduction. In the column reduction, look at this matrix. Identify the least element in the first column. Least element is 2. So it is a 2 minus 2 is 0. 4 minus 2 is 2. 3 minus 2 is 1. So 9 minus 2 is 7. And 5 minus 2 is 3. Similarly, go to the second column. The least element is 0. So I'll subtract from other elements. So this becomes 10 minus 0 is 10. This is 4. This is 10. This is 0. And this is 4. Go to the third column. The least element is 1. I'll subtract other elements by the least element. Say this become 8 minus 1 is 7. This becomes 4. This becomes 7. This becomes 0. This becomes 2. Then go to the fourth column. The least element is 2 and subtract the other elements by 2. So this become 3, this becomes 7, and this become 1, this becomes 0, and this becomes 7. So go to the last column. The least element is 0. You subtract from other elements. This becomes 0, 0, and 0. So now the next step is allocation. See, I did row reduction, column reduction. Next, I will go for allocations. In allocation, first go with row wise, then go for column wise. In the identify the row having single zero element. So in the first row, we have two zeros. I will not allocate. And look at the second row. In the second row, you have single zero. So allocate this zero. Allocate this element. So now I'll allocate this element, and I'll cancel the corresponding column. So I'll cancel this. This is my corresponding column. I'll cancel this corresponding column. Next, go to the third row. We don't have any single zero. Go to the fourth row. We have two zero. This one. I will not allocate. Go to the next one. You have no zeros. Okay. So next, go with column wise. Go to the first column. In the first column, we have single zero. I allocate this element. So allocate this column, and I'll cancel the corresponding row. I'll cancel the corresponding row. This is my corresponding row. I'll cancel this corresponding row. Then go to the second column. In the second column, you have one single zero. So now allocate this zero. Allocate this single zero element in the second column, and I'll cancel the corresponding row. This is my corresponding row. Then go to the third column, no zero. In the fourth column, no zeros. See now, check since the number of allocation is not equal to size of matrix. Therefore, the solution is not optimum. Therefore, solution is not optimum. See here, 1, 2, 3. Number of allocations are 3, and look at the size of the matrix. See, size of the matrix is 5. Size of the matrix is 5. Therefore, the solution is not optimum. To make optimum solution, so again we need to make a number of allocations equal to size of the matrix. So now this step is very important. Now I'll apply. I will reallocate the cost matrix. Reallocate the cost matrix. So how to reallocate this cost matrix? So here, identify the minimum elements which are not cancelled. See, 2 is not cancelled, 4 is not cancelled, 4 is not cancelled, 7 is not cancelled. Similarly, 1, 10, 7, 1, 3, 4, 2, 1. So these elements are not cancelled. Select the elements which are not cancelled. Select the elements which are not cancelled. See, in this case, the element 1 is not cancelled. So I'll select this element and I'll subtract from other elements. Let us take my new cost matrix. This is my new cost matrix. I'll write my new cost matrix. The minimum element is 1. So we need to subtract from not cancelled elements. See, 2 minus 1 is 1. Then this becomes 4 minus 1 is 3. Then 4 minus 1 is 3. 7 minus 1 is 6. Then you have 1. So 1 minus 1 is 0. 10 minus 1 is 9. 7 minus 1 is 6. 1 minus 1 is 0. Then go to the fifth column. 3 minus 1 is 2, and 4 minus 1 is 3, 2 minus 1 is 0, 1, 7 minus 1 is 6. Okay, and identify the elements which are Identify the elements having two intersections, row wise as well as column wise. See this element having intersection both in row wise or column wise, so I will add plus 1. Plus 1 means this element. So these are the elements I picked. This is the minimum element. So I'll add this minimum element to the two diagonal lines. Say here I will add 1, and here there is one row wise and column wise. You have two intersection lines. I will add plus 1 and write down the remaining elements as it is. So here it is 0, this is 10, this is 7, this is 3, and this is 0, this is 0, this is 0, and this element is 7, this is 0, this is 0, this is 2. This is my new allocated cost matrix. Now apply row reduction and column reduction, then go for allocation. Already row allocated, minimum element is 0, minimum element is 0. So row 1 I allocated, even column wise also you will find single zeros in every column. So next step is I will go for allocation. Identify the element single zero in a row, and I will allocate that single zero element. See here, it has single zero. Allocate this element. Now I allocate this element and I'll cancel the corresponding column. This is my column. This is my column. I'll cancel this corresponding column. Next, go to the next row. I have single zero here. Allocate this single zero. Allocate this single zero and I'll cancel the corresponding column. This is my corresponding column. Let's look at this one. This is my corresponding column. Similarly, I'll go to the next row, third row. In the third row, you have single zero here. I'll cancel this single zero, allocate this 0, and I'll cancel the corresponding column. I'll allocate this element and I'll cancel the corresponding column. This is my corresponding column. Next, similarly, go to the fourth row. You have two zeros. Fifth row, no zeros. Then go with column wise. Second column having single zero. Second column having single zero. I'll allocate this 0. And I'll cancel the corresponding row. I'll allocate this one and I'll cancel the corresponding row. This is my corresponding row. Then in the third column, no zeros. Fourth and fifth, no zeros. Now check number of allocations. Since number of allocations are 1, 2, 3, 4 is not equal to size of the matrix, therefore the solution is not optimum. Since the number of allocations are not equal, just see here 1, 2, 3, 4, which is not equal to size of the matrix. Size of the matrix is 5 by 5. Therefore, the solution is not optimum. So again, we need to go for reallocation. So now I'll reallocate the same elements. I'll write a new cost matrix. I'll write the new cost matrix. Identify the minimum element which is not cancelled in the previous matrix. So in this matrix, identify the minimum element which is not cancelled. So here minimum element is 3, here it is 1. 1 will be the minimum element. Okay. So now 1 will be the minimum element. I will subtract the other elements by 1, only uncancelled elements. Here 10 minus 1 is 9 and 3 minus 1 is 2. This is 9 minus 1 is 8 and 3 minus 1 is 2. Then go to this one. 7 minus 1 is 6. This is 2. This is 5. This becomes 0. So now Identify the intersection line. See, 7 is intersecting horizontal and vertically. I will add +1. I will add this element. So this becomes 7 plus 1 is 8. Then here 2 is the intersection elements. 2 plus 1. I will add this one. So this become 2 plus 1 become 3. Then 1 is the intersection elements. I will add 1 plus 1. So this become 2. And write the remaining element as it is. So this is 0. This is 1. This is 0. This is 2. Then this is 0. This is 0. Then this is 6. This is 0. This is 3. This is 6. This is 0. This is 1, 0, 0. Now go for allocations. So in every row and column we have minimum 1 zeros. Directly I will go to allocation. Identify the elements. Identify the row or column having single zero and allocate that particular zero and cancel the corresponding column or row. Say row wise, first row having single zero, I allocate this zero and I will cancel the corresponding column. This is my column. I will cancel this column. Then go to the second row. Second row again you have single zero, 2, 2, 6, 0. I have single zero. I will allocate this single zero and I will cancel the corresponding column. This is my column. I will cancel the corresponding column. Go to the third row. You have single zero here. Allocate this single zero. Allocate this single zero and I'll cancel the corresponding column. See, my corresponding column is this is my corresponding column. Next, go to the next row, 2 zeros. I will not allocate this fourth row. Go to the fifth row. We have single zero. Allocate this zero and I'll cancel the corresponding column. So my corresponding column is this is single zero, and the corresponding column is J3. I'll cancel J3 here. Then go to column wise. You have only one column. This column having single zero. I'll allocate this element and I'll cancel the corresponding row. I'll allocate this one and I'll cancel the corresponding row. This is my corresponding row. I'll cancel this corresponding row. So now, since the number of just look here, you have 4 and 5. 5 allocations and size of the matrix is 5. Since the number of allocation is equal to size of matrix, therefore the solution is optimum. Therefore the solution is optimum. So in the next step we need to determine what will be the optimum assignment and optimum cost. Let us see the optimum assignment and optimum cost. Optimum assignment. See, optimum assignment is just here P1 J1. It is P1 J1. This P1 J1. Then next one is P2 J5. P2 J5. And next one is P3 and J4. P3 J4. Then go to P4 J2. P4 and J2. Then P5 J3. So this will be the optimum assignment, and look at the corresponding cost. I'll calculate what is P1 J1. P1 J1. P1 J1, just look at the matrix. Just look at the profit matrix. We need to calculate what is the optimum profit. P1 and J1. P1 J1. So this is not cost, this is a profit. Optimum profit. So P1 J1 is 11 rupee, and next one is P2 J5. P2 and J5 is 0 rupees. Then go to P3 J4. P3 J4 is 10 rupees. Then go to P4 J2. P4 and J2 is 13 rupees. Then go to P5 and J3 is 10 rupees. Okay. Now the total of profit. Total profit is I'll add these elements. So we are getting total profit is 44 rupees. Okay. So this is my total profit and this is my optimum cost. And in the problem is clearly mentioned who will be the idle person. See, idle person is, say in this case, the idle person is P2, idle person. Idle person is P2. P2 will be the idle person. So with this, I will conclude my today's session. Thank you, and thank you so much.